Today I'm joined by Brian Durking from Databricks. Our featured speakers are Stephen Harrison, a software architect, and Peter Connolly, principal software engineer for Rue Gilt Groupe, who will discuss how they built a recommendation engine using Snowflake and Databricks. With that said, let's get started, and Peter, why don't you take it away?
Thanks, Harsha. Rue Gilt Groupe owns and manages RueLaLa.com and Gilt.com. We strive to create the most engaging online, off-price style destination, connecting world-class brands to the next generation shopper. We've been in business for over 10 years. Every product we sell is part of a flash sale with limited time and inventory. Products are grouped into boutiques of similar products. This could be by brand. For example, you can see the Nike boutique on the top page that contains Nike products. Another boutique could focus on Louis Vuitton handbags or Brooks Brothers suits. We also organize boutiques by theme, like a summer looks boutique might contain shorts, polos, and casual dresses. A fall wedding style guide might contain men's suits and formal dresses. Boutiques are typically on sale for 3 to 5 days only, and then products are no longer available for purchase. From a technical perspective, flash sales create some very interesting challenges. About 20% of our inventory turns over every day. This is difficult to track. Our site load is very spiky at boutique launch times, so everything needs to scale horizontally. It's like having Black Friday every day at 11 a.m. when the majority of our boutiques launch. 2 years ago, when I logged into Rue La La, we had a one-size-fits-all website. There was no personalization. I would have to scroll past pages of women's dresses and accessories to find men's clothing. Members now expect online retailers to personalize their experience. Members expect to have interesting items shown at the top of the page. Members expect you to hide irrelevant products. Providing a personalized experience has shown to increase member engagement and retention. We wanted to use this to drive year-over-year growth. When we started our journey to personalizing the member experience 2 years ago, we had a blank slate. Our goal was to produce real-time recommendations on the web and mobile applications. We knew that we needed to collect a mountain of data, make recommendations from that data, and then serve those recommendations to end users. Each of these steps presents challenges. Today, we're going to talk about how we overcame those challenges. In order to make personalized recommendations, we need to know what our users are doing on the site. We want to know what products a member looks at before making a purchase. How did our member navigate to a successful purchase? Did they search by brand? Did they open a boutique that we put on the home page? We want to know how much time our members spent on each page. How far did they scroll down the page? We also send out emails to our members informing them of upcoming sales. We want to know if they opened their email and if it drove them to the site. All these data points can tell us what our members like and dislike. Rue Gilt Groupe has up to 1 billion clicks a month, and little of it was being captured just a few years ago. So the first problem we tackled was to start storing all this data. At the time, we had an on-premise relational database, and at times, we had a single user that would create an ad hoc SQL query and forget the join condition, and they would consume all the database resources, and our production jobs would fail overnight. We needed 2 full-time DBAs with constant tuning and provisioning. Our license costs were unrealistic. We tried out open source Hive and found it could handle the volume of data, but we found that it didn't address concurrency issues, and there was a lot of contention for resources. We chose to implement our DWH on Snowflake. This provides us with a managed solution that requires no DBAs. In fact, I don't even know if our DBAs have a login. We scale up this Snowflake cluster at night when our batch jobs run, and then we scale it back during the day so we don't have to pay for the services we don't use. We now capture all clickstream data, we capture all email data, and for all practical purposes, there's no limit to the amount of data we can store. We've created a separate compute warehouses for production jobs and power users that both point to the exact same data. Because our production job uses an isolated compute cluster, a bad ad hoc query can never consume all production resources and cause errors in our production environment. Because analytics is so much faster, we've seen a growth in the number of analytics users. We now have about 200 employees that use either Tableau, analytics, or workflow tools as part of their job. That's almost 1/3 of our employees working on the data from Snowflake on a regular basis. After solving the issue of how to store the mountain of clickstream data, we turned our attention to making recommendations out of this data. Our team had experience doing data science with Python libraries like sklearn, and we considered using this for production. We tried it out, and it took hours just to load the data into memory and many more hours to process. We realized the single node solution wouldn't work, and we started looking at Spark. We considered standalone Spark locally with production and pre-production in EMR. We tested in pre-production environments in EMR. It's cumbersome to have to package up code, stand up a cluster, deploy code to EMR. Even if you automate it all, that's a lot of steps that could go wrong. EMR was always 6 months to a year behind the latest Spark release. That's when we started looking at Databricks. It runs Spark so we know it scales. The online notebooks provide interactive feedback. We can do development in a notebook, check it into source control, and promote the same code to production. There's no real administration of Databricks. We just choose the size of the cluster we want, and they handle the hardware. We have a small team who want to focus on delivering business value, not DevOps. There's no hardware provisioning, patching, or downtime for a system upgrade. All the performance problems we had with data access from standalone Python disappeared when we started using Databricks Snowflake connector. We don't have to be concerned with writing to multiple files in S3 and reading them in parallel, or creating some type of iterator to paginate through the results, taking care to purge memory when no longer in use. We just import data from Snowflake and treat it as any other data frame. One benefit of Databricks we didn't even consider is that our team spans several countries around the world. We found it invaluable to be able to collaborate in real time on a notebook. After choosing a machine learning platform, we started to build out some recommendation systems, even though we didn't quite know how we deliver it yet. One more thing we should call out that isn't shown here, we actually load a lot of the output from Databricks back into Snowflake. That recommendation data is then read from Snowflake and used for offline recommendations such as targeted emails and marketing campaigns. We also run some complex SQL against Snowflake to analyze and improve our recommendations. Let's take a look at an example of recommendations on Rue. By no means is this the only example, it's just a really good one. For one of our first applications of data science, we wanted to find the highest recommended boutique for each member in the mobile app. We ingested the full browsing history of millions of members and millions of products into our notebooks using the Databricks Snowflake connector. We wrote some Scala code in Databricks to run collaborative filtering using alternating least squares, and we output recommendation scores for all members for all products. It took 2 people about 2 months to get the recommendations right. There's no way we could do this without Snowflake and Databricks, not even close. This page shows where we ended up, an app that recommends the top boutique for you. Contrast this with a one-size-fits-all web page.
Hey, Peter, those are my recommendations. Look, I bought the boots on the left-hand side, the ones in the middle. Those are Fry boots, the ones with the buckle. And if I look on the right-hand side, the recommendations just for me are brown boots, some with buckles, some with boots, some are not boots, and all of them are Fry. It took about 2 people 2 months, as Pete said. Now I'm going to talk about architecture. And you might wonder why architecture is in a webinar on Snowflake and Databricks. And the reason is that the Snowflake Databricks solution is magical and necessary, but definitely not sufficient to get the great data that we're generating out to our storefront and mobile applications. We need to get the fresh data science in front of customers quickly, and what that means is our front-end application needs to access the data via a low latency API. So when we were faced with this, to be honest, it sounded a bit hard. We've all created REST applications in the past, and they got a bit complicated. And what made this more complicated is that every component of this needed to be fast and horizontally scalable. That's really important, and you'll see how we managed to get horizontal scalability later. Remember that the products on sale change in bulk and very rapidly. Pete said that we're changing by about 100,000 products every day. So that means we have to have low latency in generating the data too. We looked at a couple of solutions out there, and to be sure there was some of the parts we needed, but we had to cobble something together out of them. What we did instead is we took a fresh pass over the end-to-end solution, and we made something very repeatable, and you'll see how we made it cloud native. So that's why we're talking about architecture, and I hope you find it useful. Let's get to it. The first challenge we tackled was, how do we store the data? We have a lot of data, like a lot of data. And we already knew that a relational database was not practical because we tried it. We have a lot of rows of data, 100 million plus rows. And the estimated time to load all of our data into an Oracle instance that we could barely afford was about 5 hours. And that's no good because we want our data science to be fresh. Our products are changing all the time. Members are coming and going on the site. We need to track that information. So, and the other thing is, we store data in the hundreds of terabytes. We have a significant fraction of a petabyte. So we picked NoSQL, a document store. We looked at MongoDB and Cassandra. Those are the standout choices for key value stores or document stores. We could run them on our own EC2 instances. Those are the rented computers on Amazon. We also looked at Amazon Managed Service for the same thing called DynamoDB. And it was, in fact, completely managed. We didn't want to take care and feed servers just to support applications like MongoDB. That's not really focusing on the core business. So a managed solution like DynamoDB is a natural choice. And let's just be super clear about DynamoDB. It has it all, and so we were thrilled with the choice. This is the Amazon Web Services managed service for NoSQL. It has very fast query time, which we can take advantage of in our data APIs. And that's true even under load, actually even under huge load. Nice thing about DynamoDB is we have low latency to load the data. It can handle 200,000 writes per second without breaking a sweat. And I didn't misstate that, 200,000 writes a second, and that's not even close to the limit. One of the nice things about DynamoDB is you can provision dedicated capacity for reads and for writes. And DynamoDB has auto-scaling built in. So if you want to respond to increasing or decreasing loads, to adjust your provisioning for both read and write, that comes out of the box. To get the data into DynamoDB, there were a couple of options, but in the end, we ended up writing our custom importers, but in Docker containers, run on AWS Batch, which is the Amazon Batch service, as it sounds. And here's where we ended up after we figured out how to store the data. So this is the ML data coming out of Databricks that has been pulled and processed out of Snowflake, and then our batch import process puts it in DynamoDB. Next step, next thing we tackled. As I alluded to earlier, we need a data science API, and we need to make it fast because our storefront and mobile applications are calling us inline in real time when they're displaying pages. They can't hang about waiting for us to waiting for the data science APIs to respond. And in fact, they gave us a budget of 150 milliseconds for the call, which we didn't even know if we could. We went for it, and actually you'll see that we surpassed that. Our North Star for what we wanted to do for the API was kind of a negative approach. We started with our, I suppose you'd call it, South Star of what we didn't want to do. And it might sound negative, but actually it was super helpful. Let me go through it. We decided that we wanted the exact opposite of clusters of licensed JBoss application servers, obviously we pay for licenses, running on an operating system that we pay for, say Red Hat, on hardware we own, in a data center cage we rent. So that was our guiding light, or pushing light or something, but that drove us in a direction to be cloud native and managed services. One of the advantages of this is its pay-per-use. So we don't have an upfront cost. Every tier of our architecture is elastically scalable, and we only pay for how we're provisioned at a point in time. And just a note on why the data science API must be fast. Time is money on a retail site, and in fact, we can prove it. So delays for loading the page are frowned upon here, actually frowned upon quite a bit. Incidentally, we can load a web page on our storefront application in about 400 milliseconds, which we don't want to lose sight of that. We picked another managed service for the REST endpoint, API Gateway. It's pretty nice. It scales really well and is pretty economical. So that's dealing with our REST endpoint. Now, to get data to and from DynamoDB, we have a couple of shims, and they're really, I call them shims because there's really no code being executed. It's just essentially a pass-through. It takes the URL data on one side, calls DynamoDB, which is a really simple API and fast, and returns the data to the application. So this is the story so far. We've got NoSQL, DynamoDB, and we've got REST implemented in API Gateway and Lambda. And this is if you don't know what a Lambda is, don't worry. But think of it as a little bundle of code that can be executed at immense scale. So take a look at Lambdas if you don't know what they are. They're pretty interesting. We run Datadog. This is our show-off Datadog output. Don't need to dwell on that. Okay. So now that we've got the major components kind of above the fold, everything that's sort of visible to the data flow from left to right, we're going to talk about the tool chain. And again, why are we talking about a tool chain in a webinar that's Snowflake Databricks? Well, this is our story using those managed services, and it includes the tool chain. And you'll see what that is in a second. So we wanted a tool chain to tie together all the components, right? It's our path to production. It's how we get data from one place to another. It's how we promote code from development to QA to production. We use cloud services even for the tools. So an example of that is we use GitHub, which is Git as a service. I'm sure everyone's heard of it. And contrast that with a sort of legacy approach where you're running something like Subversion, which predates Git by a long time, on a server and have to manage it and whatever. Git as a service has been a real boon to us. We've taken the Databricks notebooks that we've created in development, and we have made sure that we parameterize those notebooks with the environment, so dev, QA, and prod. And we're careful about this, but what it means is we can run the same notebook that we were developing on in QA and production, just with a slightly different environment variable. And that's really great because that really helps our path to production. Our toolset has to be pretty flexible and pretty easy to explain, and familiar tools. I've got even to data scientists there. That's not meant to disparage data scientists, but listen, not everybody is super comfortable on the command line. Some software developers are not, some data scientists are not. So we had to make sure that our solutions really took that into account. And this is where we ended up. This is the full picture now with the tool chain. One of the things we like about the whole architecture end-to-end is it's really easy to explain. And that's a boon. For people coming on to our team or explaining to other teams that we're working with, it has to be easy to explain. The API gateway that we're using, our REST endpoint, has to be fast and reliable, and we'll talk a little bit about that later. And as Peter alluded to, we very often take Databricks output and back into Snowflake for downstream machine learning jobs. We're 100% managed services, 100%. So we don't have to spin up any of our own servers, nothing. And we have 0 downtime deploys, and that's actually kind of exciting for me. Whole architecture and the tool chain is open source. Again, it's easy to learn and very repeatable. Now I'm going to take you through our daily routine, just to pull together the tool chain and the sort of sequence of events, just so you can see kind of a day in the life of a data scientist at Rue Gilt. And here we are. This is simplified, and it isn't something we all do every day, but we do parts of this every day. It would be a little unusual to do the whole cycle in a day, but we do some of it every day. And let's see, there isn't a really good place to start. Okay, let's go with Databricks running in production. So this is a production notebook, and it's pulling data out of Snowflake via the Databricks Snowflake connector, and that's in production. And say you want to make a change to this. Well, you pull down, we have a tool we use called Bricker, you pull down the production notebooks into the feature branch that you've created in Git. This is pending work, if you don't know what a feature branch is. And we create that feature branch, and then when we pull down the production notebooks and Databricks, it'll be a copy of production. But then you change it either in Databricks notebooks or supporting Scala and SQL code locally. You end up with all the changes for everything in your feature branch. And then we push it up to GitHub, do a pull request, which is just a fancy name for code review. A nice thing about pull requests is it's just a cloud-based code review. In the last few years, I guess before GitHub, code review had kind of a dirty name. I mean, it was a place where you get a bunch of people poking fun at one other person in a room, and it wasn't really fun. We have the same kind of back and forth and banter in pull requests that we enjoy in Databricks notebooks. It's highly collaborative. It fits very well with the Databricks paradigm. When we're done with the pull request, gets approved, merge that to the release chain, and that triggers AWS Code Build, which is, guess what, it's a managed service for building stuff, and that's a continuous integration, continuous deployment framework. It goes straight into production. And then we start the cycle again. Once it's in production, Databricks pulls data from Snowflake, and that's about it. So let's review. This is our end state, and I put no compromises because I think that's true. And you be the judge, but we're pretty happy where we ended up. We wanted to be fast to production. As Peter alluded to, we don't want to write code and bundle code and submit it to, say, Elastic MapReduce, wait for it to fail, look at the log to see where it failed, edit it again, bundle it again, push it up. That isn't interactive. That's a batch process. What we have with Databricks notebooks is interactive development, but not just for one person. As Peter alluded to, we have a team around the world. You can interact in real time in Databricks notebooks. Think Google Docs for machine learning. Again, the data warehouse, we just wanted uptime, speed, scaling. We didn't want to have to think about it. Snowflake gives us excellent SLAs, very elastic. Again, a note on Databricks, our turnaround in hours is now minutes. It's great. When we started the architecture, we were pretty sure we wanted to be, quote, in the cloud. And I've done cloud deployments before, so I was thinking I would bring up our own servers and blah, blah, blah. We actually didn't do that. So we didn't forklift an existing architecture into EC2 instances, the computers you rent on Amazon. We went completely serverless, completely managed services, 100% cloud native. I mentioned our API latency budget was 150 milliseconds. We beat it by an order of magnitude, 16 milliseconds, as the Datadog snapshot showed you. And I got a note here. I don't know about you, but I find 16 milliseconds hard to, so to say, visualize. It's probably quicker than the blink of an eye, probably much quicker. So what I've done is I've converted it to a frequency domain, and guess what? It's 60 hertz. And we're actually familiar with that sound, which you can hear, that note, if you stand outside an electrical substation, which I'm sure everybody does regularly. That's the noise you can hear. That hum is 60 hertz. And when you think about it in those terms, at least for me, that gives you a sense of how fast it is. We were 3.5 nines uptime was our budget, and we're 100%. On the way to the studio this morning, Peter and I were discussing, well, if we say 100%, we better be 100%. So we racked our brains, like, is there a failure that we didn't notice? And we don't think there is. We monitor it very closely. We haven't seen a drop request. We haven't seen wrong data. It's 100%. And as I mentioned, our deployment downtime is 0. And we've given 10 minutes. So that's a summary of where we ended up with the Snowflake to Databricks machine learning component, and then the last mile, getting the data out to our applications. That's what I got. And one final note, it just works. And we're very proud of that. And we've actually come to rely on it. Now with that, I think I'm ready to hand it back to our hosts.
Okay, thanks, Stephen. Before I go into this last slide here on what we've done with Snowflake and Databricks together, I just want to remind everyone to please submit any questions you have through the Q&A window in your console, and then we'll open it up to some questions after this last slide. So on the Snowflake and Databricks kind of better together story, really about unifying big data and AI, some key value props just to highlight that I think Stephen and Peter already kind of covered in their presentation. So number one, the connector is now built in. We announced this in late August, but all required jars, libraries, everything is preloaded in the Databricks Unified Analytics Platform runtime. We jointly keep these up to date where we've got a support cadence with Databricks, so we make sure that we're doing testing on our side, they're doing testing on their side. So it takes all the guesswork, all the maintenance of the integration, out of the picture. We have optimized this integration using query pushdowns. So queries that can be translated to SQL will be automatically pushed down to Snowflake. There's no manual configuration needed there. And it just works, as Stephen was saying, so you don't need to worry about what gets processed in Spark versus what gets processed in Snowflake. And as part of this built-in connector and integration, there are quick start notebooks. There are Snowflake's available in the Databricks dropdown to get started. You can secure your credentials using the Databricks Secrets API. So all of this is really designed around ease of use, scalability, future-proof in terms of getting started with the integration. Another key point is really kind of inherent to both of these solutions, which is being fully managed and elastic. And Brian, maybe you can chime in quickly on the Databricks value prop there.
Sure, glad to. Thanks, Harsha. A couple of things about Databricks Unified Analytics Platform that the team has covered here, which I'm really excited about. It's a platform that unifies data engineering and data science, and we do this through the notebooks that drive collaboration and productivity. And that's something that Peter talked about in terms of their international teams being able to collaborate. And I think one of the things that most customers see out of that is it really helps accelerate innovation that these teams are able to work together in a single place instead of being siloed. Another item that was mentioned is the fully managed clusters and the ability to auto-scale and auto-terminate. And Stephen talked about that ability. And that really takes the need to manage, the entire system, as you talked about, out of the hands of the folks who are doing the data science and the data engineering and all of that work. So that scales up when a big job comes up, and then scales back down and cuts your costs because it's not running while you're trying to when you're idle and everything. So overall, what we see is a simplified end-to-end machine learning workflow that I think has really made a difference for Rue Gilt Group. Thanks, Harsha.
Yep, thanks, Brian. And a lot of this is the same with Snowflake, and that's what makes these two solutions so great together. We talked already about how Snowflake automates all the maintenance tasks. There's no vacuuming, there's no partitioning, there's really no maintenance tasks at all that you need to perform. And then in terms of scalability, it's really the same story, right? You can instantly scale up these clusters, scale them down. I think Stephen alluded to that fact. We have customers that will scale up any thousands of nodes at one point, run a bunch of throughput and scale it back down, and only pay for the time they actually used. And the last key point here is really the native support for semi-structured data, and in particular JSON. There's a lot of transformation needs for manipulating JSON before you put it in your relational database, and that goes away with the Snowflake Databricks integration. So now you can focus on your machine learning, on your ETL or advanced ETL in Spark, but JSON is natively handled by Snowflake, so that takes out some of that additional complexity and just really optimizes that integration. Okay, with that, it's now time to open up everything to live Q&A. So if you've got any additional questions, please feel free to submit them. We'll start picking up some of the questions we've already seen and get started on those now. Let's see. All right, I'm looking at a question from, let's see, Toyota Financial. How do you stream real-time data into Snowflake?
So what we do is
Peter,
do you
want to take that
one? Yeah, it's Peter here. So what we do is we have the storefront send every click to AWS Firehose, and AWS Firehose, on a batch basis, every few minutes, is going to take all the requests, create a CSV file, common delimited file out of it, and it's going to dump it to S3 for us. Then we have a job that comes in periodically. It loads those S3 files directly into Snowflake using a copy command.
Okay, we've got a few more questions here. Thanks, Peter. Another question is, can you comment on the learning curve for folks to absorb and master Snowflake plus Databricks plus ML from your legacy stacks?
Yeah, this is Stephen. I think I can do that. We've had a little bit of experience doing that, people joining the data science team. There are really three different pieces to that. I'll cover it briefly in three parts. You've got to be fairly adept at SQL to get the most out of Snowflake, no question about that. You've got to be pretty good at Apache Spark to get the most out of Databricks. I think those two things are a given. On the architecture side, we have really had no problem at all bringing up new people on the idea of how we're architected and what it takes to deploy something. Frankly, it's about as simple as a deployment itself. We have a simple wiki page, and everybody follows it.
Great, thanks, Stephen. Another question we've got here is around cost. What's your average monthly cost? Architecture sounds fantastic, but pricing and budgeting something like this seems like a black art, especially during sales spikes. If you could please talk about cloud costs and budgeting for us unfamiliar with the cloud services.
Yeah, I got this one too, if you like. It's Stephen here. I can't go into the specific costs of everything, although of course I know it, but I can give you some guidelines. So our monthly budget for all development, all QA, and all production, including all the Databricks clusters, all the Snowflake, and all of our clickstream inbound traffic, which is in 1 billion clicks. It's over 10,000, but not much over 10,000. And again, I'm sorry I can't get into the specifics. I'll tell you one thing though. API Gateway for these billion inbound requests a month is super economical. We're very, very happy with that. Hope that answers your question.
Great, Stephen. Another question that came in is, what data visualization technology is used, and is it fully managed as well?
Hi, it's Peter here. We use Tableau mainly for visualization. I believe we're using Tableau Online. We also have analysts that will do custom SQL. We've also got data scientists that will use other types of tools to visualize, like whether it's Python packages. So there's a lot of different ways to look at it, but primarily Tableau.
Okay, great. Another question is, how do you create pull requests that contain both notebooks and supporting code?
This is Stephen here. I can take that one. Yeah, as I alluded to previously, that's something we make a point of doing. We start off with a copy of production, right? So in Git terms, that's the master branch. Then we create a feature branch, which is the code that we're going to work on. And through the Bricker tool, which is another open source tool we use, we can keep that in sync with Databricks. So our local copy and the local feature branch and Databricks are kept in sync. Then in an IDE or whatever, and Databricks or the notebook, we make all the edits. Those all converge in your feature branch. And then when we're ready to have a pull request, we push that up to Git. I hope that answers your question.
Great. We'll take a few more of these that I see in here. Could you talk a little bit more about pushing data from Databricks to DynamoDB? I think you had mentioned custom Docker-based loaders.
Yeah, for sure. This is Stephen here. This is the part that this is the most sort of innovation, if you like, we had to do. We tried a couple of things. Unfortunately, DynamoDB, as it is, doesn't have a native import mechanism. There are some attempts at that, actually one or two by Amazon, but it's a bit finicky to get right. There's an ETL service that's kind of new in the last year at Amazon called AWS Glue. And last I looked, unfortunately, Glue didn't support DynamoDB. So we had to write our own importer. This is also serverless. We're running Docker containers. But the code is pretty small. It simply reads files from S3 and converts them into calls intact to DynamoDB items. It's a pretty simple importer. It's a little bit multi-threaded. It can take care of any throttling that might occur. So, it's a little bit involved there. But it's actually pretty simple. And all of our data science uses the same methodology. Again, I hope that answers your question. If not, we'll find a way for you to contact me.
All right, why don't we do two more questions here, Stephen and Peter. So one other one that just came in is, what kind of models does this architecture support?
So this supports any type of models that Databricks supports, really. We could even take it a step further and say we want to run some standard Python libraries, and we do that on occasion as well. So Databricks will support recommendation models. We've got some deep learning stuff going on that we're trying out. We've got things like Gaussian mixture models, predicting what our customers will do. We've got categorization going on, trying to cluster our members into different groups. So there's a number of different models that we use behind the scenes.
Great. Okay. One last question here before we wrap up would be, how are you handling security and governance in the solution?
So I'll take that one, Peter here. So for security and governance, what we've done is we've locked down Snowflake so that only certain people have access to it. And even within that, we don't keep any PII data, no personally identifiable information to start with. So We don't need it to make recommendations. We just need to know that user ID 12345 purchased certain things. So we use that to make the recommendations. And then all the data stays in our VPC. So we lock down access to Snowflake so that only people in our firewall can get to it. We allow only people in the VPC to access the data. And then from Databricks, we lock it down so that only certain people can access the notebooks.
Yeah, this is Stephen. Just on the tail of that, at Rue Gilt, we will go to any lengths possible to avoid PCI compliance. So we use a payment gateway that does the storage of all the PII for us. So we don't even have the data on site.
Okay, great, guys. So with that, I think I just want to thank everyone, thank our attendees, thank our speakers. We'll be sending out a link to this webinar within 24 hours. And for everyone, we hope to see you again in the future for a future webinar. Thank you very much.